Good everyone, it is your favorite tutor, and today is your favorite tutor on physics. All right, what I have on the board, expansivity. Remember in our previous class we discussed about what expansivity had to do with what expansion of what material due to the effect of what heat. And then we have a linear expansivity, that is a increase in length. We have area expansivity that has to do with what increase in what area, and volume expansivity, increase in volume. All right, I have a question on the board. Okay, we are going to solve this question. It says the linear expansivity of a cube is 12 times 10 raised to the power minus 6 per Kelvin if the length of each side of the cube is 10 centimeter. Calculate the area of one face of the cube. 2. The volume of the cube when the temperature is raised by 30 Kelvin. All right, let's do this. First of all, let us bring out the parameters out. Let us bring out the parameters. Okay, we have the linear expansivity of what? 12 times 10 raised to the power minus 6 per Kelvin. And then we have a length of the cube. Length of the cube is 10 centimeter. Okay, we are looking for what? Area of one face of the cube and then volume of the what? Cube when the temperature is raised by 30 Kelvin. Now, a cube. We are talking about what a cube. A cube has 6 faces, just like your dice, or more like your cube of sugar. You have a 6 face. Yeah, something like this. Something like this. This this box right here. Yes. Okay. Now this is the cube. What we are looking for is area of the cube when the temperature is being raised by 30 Kelvin and volume of the cube when the temperature is being raised also by about 30 Kelvin. That's the face of the cube. So if you are talking about what? The face of the cube. There's the face of the cube. One face of the cube is a square. One face of the cube is a what? A square. Okay. So before the temperature rise, what is the what area of the cube of this face of the cube? So therefore area 1, that is before the increase in what temperature. If one length of the cube, know that a square is what area of a square is what length times length, and length of the cube is what 10 centimeter. So therefore area of a square is what length times length, which is what 10 times what 10. This is equals to 100 centimeter square. Now this is what the area of the what of one face of the cube when the that is before the temperature is being what raised to what 30 Kelvin. So this is what area 1. Okay, and also we are going to look for what the area expansivity. All right, the area expansivity, because right here we're getting what linear what expansivity. Linear expansivity, since it had to do with what area, increase in area, we also need to get what the area expansivity. And we're not giving area expansivity, but we're giving what linear expansivity. Area expansivity is twice that of what linear expansivity, which is equals to 2 times what 12 times 10 raised to the power minus 6 will give us 24 times 10 raised to the power minus 6 per Kelvin. So this is the what? The area expansivity. Okay, and right here, the temperature rise is what 30 Kelvin, and we are looking for what the new area when the temperature is increased by 30 Kelvin. Okay, so we know that the area expansivity The equation for area expansivity is what? The change in what? Area, which is area 2 minus area 1, all over what? Area 1 times what? Temperature rise. And we are looking for the new area, which is what? Area 2. Area 2. So therefore, the area expansivity right here is what? 24 times 10 raised to the power minus 6 equals to what? Area 2 minus area 1. Area 1 is the original area of the cube, 100, all over what? 100 times what? 30 times 30 Kelvin. Okay, so right here we cross multiply. Area 2 minus 100 equals to what? 24 times 10 raised to the power minus 6 times 100 times 30. So what do we have? Area 2 minus 100 equals to, if we multiply these things, these values, we'll have 0.072. Yeah, we'll have 0.072. Since we are looking for area 2, we take minus 100 to the other side of the equation. So therefore, area 2 is equals to 100 plus 0.072. So area 2 is equals to what? 100.072 centimeter square. Now this is the what? The new area when the temperature is raised by 30 Kelvin. You can see that the new area is greater than the what? Than the original area before the temperature is being raised. The original area right here is what? 100 centimeter square. The new area is 100.072 centimeter square. Now, this is due to the what? Effect of what? Heat. That is the increase in what? Temperature. So, this is the answer for question 1. Now, question 2 says the volume of the cube when its temperature is being raised. So, volume of the cube. So that means we are looking for what? Volume 2. Volume 2. Volume 2. We also need to get what? Volume 1. Volume 1, that is the what? The volume of the cube before the temperature is being what? Raised. Now volume. Volume is what? Length. That is what? Breadth. That is what? Height. This is what? For volume. And one side of the cube, according to the question, it says each side of the cube is 10 centimeter. Each side of the cube. That means the cube is equal. It's equal in all what? Side. It means that the volume, since it's equal, the same thing as length times what? Length, which is equals to what? 10 times what? 10 times 10 is equals to what? 1000 centimeter cube. 1000 centimeter what? Cube. So this is the what? The original what? Volume of the what? Cube. All right. Now, the increase in temperature, the temperature has been increase in temperature, 30 watts, Kelvin. And of course, the volume expansivity. Volume expansivity is equals to what? Thrice that of what? Linear expansivity. So this is equals to what? 3 times what? The linear expansivity is what? 12 times 10 raised by minus 6 per Kelvin, which is equals to what? 36 times 10 raised by minus 6 per Kelvin. Now this is the what? The volume expansivity. Therefore, the formula for volume expansivity is change in volume, which is volume 2 minus volume 1, all over what? Volume 1 times increase in temperature. So therefore, the volume expansivity is what? 36 times 10 raised to the power of what? Minus 6. Equals to, we are looking for volume 2 minus volume 1 is what? 1000 all over what? 1000 times 30. Okay, so we are looking for volume 2. We do what? Cross multiply. Volume 2 minus 100, 1000 equals to what? 36 times 10 raised to the power of what? Minus 6 times 1000 times 30. So volume 2 minus 1000 is equals to, all right, if we do our multiplication, multiply these three values, we have 1.08. Yes, 1.08. Okay, so we take minus 1000 to the other side of the equation. So this is what volume 2 equals to what? 1000 plus 1.08. You can see it minus 1000. We turn this to what? Plus 1000. And we cross over the equality sign. So volume 2 is equals to what? 1001.08 in what? Centimeter cube. All right, ladies and gentlemen, this is the what? The new volume when the temperature is being raised to what? 30 Kelvin. We've come to the end of this episode. Please stay tuned. Make sure you subscribe to get notification of all my incoming videos. I remain your favorite tutor. Thank you and God bless you.